Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. Are you ready for the soundness of the substitution of equivalences rule? I hope so, because that's what we're going to do today. So I will bring up the whiteboard because we are going to need to write down a lot of things. First of all, a reminder of what it is that we need to prove in order to show that this rule is sound. So remember that the rule says if phi is a theorem, and you have another theorem, the provable equivalence between two formulas chi and gamma, then if you have another formula psi, which is just like phi, except wherever phi has gamma, or wherever phi has chi, psi has gamma, don't worry, I'll write this down, then the result will also be a theorem. So in order to prove the soundness of this rule, we need to show that it's truth preserving. So that is, if phi is valid and the biconditional between two formulas chi and gamma is also valid, and we have a formula psi which differs from phi only in having gamma, where phi has chi, then what we need to show is that psi itself will also be valid. Now, the soundness of this rule is based on a number of propositional equivalences and implications. So these are all propositional tautologies, and therefore they are all going to be axioms of K. They are, first, that if P is equivalent to Q, that equivalence is equivalent to not P if and only if not Q. Second, if P is equivalent to Q, this itself is equivalent to P or R if and only if Q or R. So I can always add a disjunct on the right. And finally, if P and Q are equivalent, this equivalence is going to be equivalent to putting a disjunction on the right. So if P is equivalent to Q, then R or P is equivalent to R or Q. Now, these are all propositional tautologies, so they are all axioms of K, and they are all valid. Now, you'll note that these only involve negation and disjunction, but because of our normal form lemma, we don't need to consider any of the other propositional connectives. We don't need to worry about conjunctions or implications because we can always reduce them to the case of just negation and disjunction. So suppose that we do in fact have the provable equivalence between two formulas chi and gamma. Now, by basic modal reasoning, so using uniform substitution, modus ponens, and derived rule 2, which is the one that says if you have a biconditional, you can put boxes on both sides. These three rules, along with these three propositional tautologies, all give us the following. So we can derive these facts. First, that not chi is equivalent to not gamma. That comes from the first one. That chi or beta is equivalent to gamma or beta, and this follows from the second one. That beta or chi is equivalent to beta or gamma, and that comes from the third. And then using our derived rule 2, we have that necessarily chi is going to be equivalent to necessarily gamma. Now, because these are just derived using uniform substitution, modus ponens, and derived rule 2, they are all sound. And therefore, we know that if this is in fact a tautology, that all of these are going to be valid as well. So we can just go like this by earlier soundness results. by our normal form result that we proved in the last video, we know that every modal formula is equivalent, and equivalent provably using propositional tautologies and modal interchange to something that only involves negation, disjunction, and necessity. So suppose that we have a formula that is constructed out of gamma only using negation, disjunction, and necessity. So let's spell this out. So let alpha be with constructed from chi using negation, disjunction, and necessity alone. So psi would be an instance of something like this. It is built out of chi, possibly other things as well. But the point is that anything that we could build up from chi, we could also have built up from gamma, because these things are both provably equivalent, and the equivalence between them is valid, whatever logical system we are looking at. So that's just kind of the route where we're going. So alpha is a formula constructed from chi using negation, disjunction, and necessity. And then let beta be another formula that is constructed from gamma. So the other half of the equivalence, again, using negation, disjunction, and necessity in exactly the same way that alpha was constructed from chi. So for instance, suppose that we have p on one hand and not p on the other hand. So if this is our chi and this is our gamma, then alpha could be constructed by saying p or q. Then beta would be constructed by saying not p or q. So there's just an example of how this works. So it now follows that if we have the equivalence between chi and gamma, if this is a tautology, then the equivalence between alpha and beta is also going to hold. Because if you start off with things that have the same truth values and you construct formulas out of them in exactly the same way, they're also going to have the same truth values, because that's how compositionality and truth functionality works. So from this, we know that alpha is provable in a logical system if and only if beta is. Because suppose that you had one but not the other, then you would eventually, through modus ponens, you would be able to determine that your system was unsound because you have a conditional and its antecedent, but you don't have its consequent. So modus ponens would fail if we had one of alpha but not the other. So substituting equivalent formulas preserves validity. There you have it. So whatever way that we could construct psi out of chi, if it is the same way that phi was constructed out of gamma, there's never going to be any way in which their truth values can end up diverging. Which means then that if we then kind of go from the provability of phi and the provability of chi, if and only if, sorry, that needs to be gamma. If we go from this and then say, well, psi is also a theorem, kind of by fiat, this is how rules work. We know that we will never be in a position where if we assume that the initial formula and the equivalence were valid, that the formula we have derived would not be valid. And that's all that we need for soundness. Now that we have this rule, we are going to use it all the time. We will also use it to introduce a couple more simplifying conventions in our proofs. We'll talk about that in the next video because this one's gotten long enough. So I hope to see you again soon. And until then, take care. Cheers.